Do want to say hello to everyone this morning or this afternoon, depending on where you may be. My name is Hans Schmitz, and I'm on the leadership team for the North Central Climate Collaborative. We try to provide one of these webinars about every other month. Welcome and please stay tuned for future offerings. A little bit about the webinar today. We are back in a Zoom format. We've been in WebEx for a little while and decided that Zoom was the way to go. We will be entertaining questions at the end of the day today, into the webinar. And those questions, if you would like to submit them, please use the chat box. We have disabled people from being able to unmute themselves because we do have a rather large webinar today. So please do use the chat box if you have any questions or want to reach out to any of us. If you have any technical issues, I'll be available to assist in that. We do have just a couple of polls today, and I'm going to go ahead and start our pre-webinar survey, if you wouldn't mind filling that out. We are very pleased today to have the University of Minnesota's Heidi Roop with us to discuss the Intergovernmental Panel on Climate Change reports. Heidi is familiar with those on the inside, and without further ado, then I'll turn it over to her.
Great, thank you. And thank you for the invitation. And thank you all for joining me for this lunchtime/afternoon discussion. I'm going to go ahead and put my slides up here. And we're going to dig in. And so I will caveat this entire presentation with the fact that we are together going on a journey that is trying to unpack in under an hour over 3,000 pages of science, representing over 14,000 peer-reviewed studies. So inevitably there will be questions. I'm going to do my best I've done my best to sort of provide you with the Cliff Notes version, some of the key takeaways, a little bit of the regionalization of the report. What does it mean for us in the sort of greater Midwest region, what the IPCC refers to as Central North America, sort of the big bin of geography that I sort of leaned on today. And so we're going to unpack that from sort of what's new in the report, what is it saying about the state of climate science and its impacts across the globe, and critically, what do we do and the urgency to act. So I'm a faculty member at the University of Minnesota and an extension specialist focused on climate change and adaptation. I am an earth scientist by training. I've spent most of my career developing records of climate variability and change, including those from ice cores and lake sediment cores from our polar regions. Some of the paleoclimate evidence, actually one of the neat, maybe nerdy aspects of this sixth assessment report we're discussing today is that instead of a separate paleoclimate chapter, as has been common in the past through previous syntheses, they've actually incorporated and woven in paleoclimate evidence like that from the ice core record directly into the report itself. So I do now spend a bulk of my time focused on application. So thinking about how is it that we generate usable and actionable climate science information to help our communities prepare for the changes we know we've set in motion. And I'll unpack a little bit of that in this report. I, as part of my role in the state of Minnesota, lead a program called the Minnesota Climate Adaptation Partnership, which is really at the heart of this sort of use-inspired and actionable science in service of building resilience and adaptive capacity across multiple sectors in Minnesota and the greater Midwest region. So sorry, I'm having an issue. I need to just go on a screen share to get the poll off the middle of my screen. So I'm going to do that just briefly here. Apologies for that. I'm going to play again. All right. So what we're talking about today is the sixth assessment. That's what the AR6 stands for, of Working Group 1. I'm going to unpack this a little bit more, of the Intergovernmental Panel on Climate Change's regular series of updates that they provide to a variety of topics. I'll unpack each of the core working groups' focus areas. What we're talking about today is the contribution provided by Working Group 1, which focuses on the physical science basis of climate change. These reports go way back to the 90s. Sort of a joke here for those who are familiar or grew up in the 90s as I did. This is a time when Tamagotchis were famous and useful, and the sort of state of our technology. And of course, along with advancements in technology and our observations and our monitoring, we use the Intergovernmental Panel on Climate Change report process to update our state of knowledge around a variety of key topic areas. The report itself, the 2021 version, was released in August, and there's sort of good timing to this as we lead into the climate negotiations that will be happening at the Conference of Parties meeting at the end of this month and the first week of November. And we'll talk a little bit about that as well. So what is the IPCC assessment report? It represents hundreds of authors from around the world coming together, importantly, volunteering their time. These are not paid contributors, contrary to some misinformation out there. They come together and they synthesize the state of the science. They review over 14,000 scientific publications for this particular report. They address directly tens of thousands of review comments. They negotiate and work through approval of the draft by member countries. And they are basically synthesizing a huge volume of science to communicate clearly and explicitly what climate change means for the globe. The summary for policymakers, which is sort of the short version of the broader report, represents approval, a line-by-line approval and agreement by IPCC member countries. This is over 120 countries going through with their delegates, approving the summary for policymakers, which are the sort of headline statements that I'll unpack here, but that you'll likely have seen in the media. Authors of the report, these sort of 200 plus authors that dedicate their time and expertise to creating the synthesis report, ensure that any suggested changes by member countries are consistent with the underlying report and are scientifically robust. This also includes making statements around the confidence that we place in the different observations and data and the models. And the overall goal of this process is direct, clear, and unambiguous synthesis summary report. So this is all to say, this is an exhaustive, comprehensive, critical, something that benefits all of us and is a huge undertaking. This, as I said, is sort of one of a whole part of the sixth assessment process. There were some special reports that have been previously released in 2018 and 2019. You may have seen there's a special report on the oceans and cryosphere, for example. There was a special report on global warming of 1.5 degrees Celsius. So there are a range of reports, and then there are these sort of consistent working group reports. So there are more reports on the way, so more to come, but wait, there's more, as there always is with this work. But the working group report 1 represents sort of the first of 4 key reports. So there's a second report coming out anticipated in February of 2022 that will focus on climate impacts, adaptation, and vulnerability. So what we're talking about specifically in this first report is the physical science basis. The third report focuses on mitigation of climate change. These are the sort of emissions pathways and trajectories, unpacks all the contributions, sources, sinks, and how we achieve the targets set forward in the Paris Climate Agreement. And anything that that emerges in terms of the nation's commitments that get articulated at the COP meeting. And then there's a synthesis report that will be likely published at the end of 2022, sort of pulling together these key pieces. So that's just sort of contextualizing where we are in this process. This is not the one and done. Building on decades of previous work, it's representing the advancements in the science and our understanding of the system, and dovetails with other reports given the complexity and interconnections of climate change, right? It's everywhere. And the science is multidisciplinary. And so these reports aim to synthesize this rich literature that spans all these disciplines. So report basics for this report. It is a comprehensive synthesis of global climate change science. It's broken out into 12 core chapters. It's about 3,000 pages all up. It includes updated models and scenarios, and I'll unpack that a little bit because it's going to help us understand some of the graphics that come out of this report. And again, that you'll likely see if you look at the summary for policymakers, or if you do a deep dive into the content. So we'll unpack some of that before getting into the so what of the report. This report represents significant advancements in attribution science. This is sort of simply the fingerprinting of climate change on weather-related events that we experience, hurricanes, floods, heat waves. This is attribution science. To give you a concrete example, is coming out and saying that the Pacific Northwest heat waves we experienced this summer could not have happened in the absence of human-caused climate change. This is sort of a representation of attribution science, right? How much of a single event can we connect to or fingerprint back to anthropogenic or human-caused climate change? So this report synthesizes some of those advancements that have occurred since the previous assessment that was published in 2013. It critically advances our understanding in climate sensitivity. This is sort of what happens in terms of temperature for every doubling of carbon dioxide in the atmosphere, sort of really understanding what is the planetary response to that forcing. So they've sort of narrowed that, and I'll unpack that a little bit further. They're narrowing the range of future temperature projections. So this is important. They're sort of narrowing that envelope of the potential range of future temperatures out towards the end of the century in the hopes of making this more actionable. What are the risks that we are assuming and that we need to plan for? And what are the risks that we can avoid through rapid decarbonization of the economy? And it includes, for the first time, regional chapters and an interactive atlas. And I encourage you to check out the summary for policymakers and the interactive atlas. This just gives you an example. They've sort of tried to make a bunch of the information because of they've now added these regional chapters in. There's regional fact sheets. I'll show you a little bit of the sort of North American version of the fact sheet and the data that are in there, but to really understand and sort of drill down to a geography of interest, I encourage you to check out the interactive atlas, and the link is there on this slide, but it should be you can even just pop in your favorite web browser, interactive atlas IPCC, and it should pop right up. And you can explore different possible climate futures. You can unpack precipitation and temperature. You can look at a range of interactive figures for an area globally that you care about. I will caveat this entire presentation and all of this. Some of you may be here to learn about what exactly is going to happen in a city that you care about or a landscape that you really care about. And the IPCC on this sort of global scale is not kind of driving that hyper local regionalization of the science, but it provides a strong foundation for researchers who do that work, who do regional downscaling of global climate models, for example. So this should provide you with useful information. The extent to which it's actionable depends on the sort of decision context in which you're using the information. But that is not to discourage one from understanding the high value and power of this, but it's not the place to look for sort of really, really place-specific downscaled information related to future climate impacts. Again, this will provide the foundations upon which future science will work, and in particular, incorporation of the next generation of global climate model output, which is at the heart of this report. So for those of you who have interacted with previous IPCC reports and previous climate model projections, there is a new suite of scenarios that they are using for the sixth assessment process. So don't be mad at the messenger. I was not part of this process, but for those of us who have just gotten used to RCPs, which is the representative concentration pathways, these are sort of the emissions trajectories that we look at to sort of understand what are the range of possible outcomes for things like temperature, for our global average temperature change. Those RCPs there are now SSPs. These are shared socioeconomic pathways. So I'm sorry, you're going to have to start to get used to using new terminology. We need to, for those of us who provide climate services and climate change and sort of technical services, it's incumbent upon us to start doing this translation and putting together resources and materials that help show the relationship between the RCPs and the SSPs. They are not the same. These shared socioeconomic pathways were chosen because they provide us with a wider selection of futures to simulate and therefore plan for. So this actually represents the inclusion of a new pathway, and I'll outline that in a subsequent slide. But essentially what this report uses are 5 new illustrative scenarios. These are sort of storylines, which span this, quote, wide range of plausible societal and climatic futures for limiting warming, right? And so these are, they basically use scenarios, and incorporated within these numbers and this jargon are different amounts of energy use, regulatory sort of policy, land use, greenhouse gas emissions, and they reflect and they are used to drive the climate model output, so we understand sort of what is at risk depending on which pathway we follow. And so again, I apologize, there is more language here to unpack and more jargon, and we have to sort of cue our eyes and ears and heads into this new way of looking at these sort of range of possible future outcomes. But I think it does better reflect the range of options and is going to be more useful in a planning and risk management context, given the addition of the scenarios and a refinement towards the high emissions scenario, which was RCP 8.5, which had a range of issues that are well documented in both news articles and the literature. So these scenarios are, and sort of to that point, this high emission scenario, the sort of basically do nothing, not the worst case. The high end of the SSPs better explore the baseline of no climate policy. So basically like no intervention, which is not the path we're on. And so they have added new scenarios that reflect the outcomes that we would anticipate that sort of are in line with the commitments and the trajectory of emissions that we are observing and that we anticipate. So it's sort of not worst case scenario. And so this represents, again, a real improvement, I think, and will hopefully lead to a more consistent and perhaps broader incorporation and use of and decision making using these future projections. There is, and again, I'd be happy to share some of this information and where to get some of these graphics, but they do articulate very clearly what is involved in each pathway, what each SSP represents. The numbers do align with the RCPs to help people kind of make that crosswalk. But again, there are some important differences and nuances between them. So they're not an apples and apples comparison, meaning SSP 8.5 is not directly analogous to the RCP 8.5. And again, sort of lots to unpack depending on your use context for this information. The IPCC assessment is relying on and using what we call CMIP-6. This is the next generation of global climate models that come together through the coupled model intercomparison project, which basically generates a set of standard simulations of future climate. Right, they're basically using the SSPs to look at what happens per emissions in the global climate system through these simulations of future climate. So this actually is an important process. It's been underway for a while. CMIP-5 is what informed the previous assessment. So right, as these reports improve, there's a sort of other process happening coordinated by the World Climate Research Program, which is representing the improvement and advancement in our global climate modeling capacities. And there's been huge technological advancements, increases in access to supercomputing, and so on and so forth. And so that is what is represented in the projections that you're seeing. The report does include output from CMIP-5 from the previous assessment, which is widely used. This is probably, as you probably use and interact with that information from CMIP-5 before. So this is, again, just reflecting an updated set of global climate model output. And it's done in a consistent way to allow for comparison. The CMIP-6 models themselves represent new and improved representation of physical, chemical, and biological processes. This includes how weather systems that bring wind and rain and clouds are represented in the models, and aerosols, sort of what are the drivers and what are the outcomes. It includes improved simulation of mean state climate and large scale indicators of climate change. This is basically a fancy jargon for saying it's improving our understanding of Earth's climate system and making it more and more granular, and basically improving our understanding. The projections we have higher confidence in the projections themselves. Importantly, there's a higher sensitivity, sort of this it's contributing to basically narrowing the envelope of what temperature projection we expect at the end of the century. So this is really important. This climate sensitivity piece is a really important one in the climate science and the climate modeling communities, because it better helps us understand how well do the projections capture what we anticipate at the end of the century based on what we've observed. And then critically, models are not crystal balls. They are projections, not predictions. And there are still differences between what we are observing and what we are able to model. And so there are always improvements, right? This is the beauty and the challenge of science. But this is all to say that models are an incredibly useful tool, but they do not predict the future. They are projections of a range of possible outcomes. And while they are great and rapidly improving, and they provide us with really critical information, it's still critical to be a savvy consumer of the information, depending on how you want to use it. Okay, Heidi, finally, so I've given you the background. What is the that's sort of the lens through which you can view this report, but what does it actually say? And the good news is that I can show you that in one slide. Here's 3,000 pages in one slide. What does this report say? It says very clearly, and I'll unpack each one of these. I'm not going to end the webinar here, but it does very clearly say that it's us, meaning humans, are causing the changes we're observing. It's here. We are observing these changes. We are already living climate change. It's everywhere. Every corner of the globe will experience and is experiencing the impacts of a changing climate as a consequence of our activities. We understand pretty clearly that we've committed to a certain amount of change on a range of timescales. I'll tell you about this more. We also know very simply that the more we emit, right, the more greenhouse gases we produce, the worse it will get. And so that critically opens up this really important part of the conversation, which is that we still have the opportunity to choose. Depending on the emissions pathways that we follow, we will determine the outcome of how much warmer it gets, and therefore the extent of negative climate impacts on communities, economy, ecosystems, right? Everything that we rely on a daily basis, we still get to choose that outcome. And that is critically the important conversation that's happening and will be happening at COP26. But we also know that this report further highlights we really have no time to waste. And I will unpack one of the key questions you're probably asking yourself, which is how much time do we have left to sort of work towards these big targets and avoid the worst impacts? And I will loop that in at the end. So it's us. This is the first time that the IPCC has used language, and this was approved in the summary for policymakers. So again, line by line approval by all the participating countries, that it is unequivocal that human influence has warmed the atmosphere, the ocean, and our land. And importantly, we understand that the rate of this warming is unprecedented in at least the last 2,000 years. So it's here and it's us, and it's different, right? This rate of change is something that is not a natural cycle. There are clear connections between human-caused climate change and changing patterns and extremes like heat waves, heavy precipitation, drought, and tropical cyclones. So we understand very clearly the connection between our activities and our lived climate experiences. We understand that it's here and that it's everywhere. So human-induced climate change is already affecting many weather and climate extremes in, quote, every region across the globe. So the idea that it's not here or a far-off phenomenon, basically the observations on this report simply say that's incorrect. It's here and it's everywhere. We have warmed the planet by about 2 degrees Fahrenheit since the late 1800s. And and this report outlines very clearly that between 2011 and 2020, that decade was more likely than not the warmest in roughly 125,000 years during the Eemian. So not only if the last 2,000 years isn't sticker shock enough, we have to look even farther back in the geologic record to find these sort of nearest analogs for what we are already experiencing. We are seeing this warming accelerating. So each of the last 4 decades has been successively warmer than any decade that preceded it since 1850s. So not only is it getting warmer and we're seeing it, but this rate of warming has accelerated over the past 4 decades compared to the previous 80 years. So that diagram is sort of showing you a comparison in the temperature change in degrees Celsius for the period at 1900 to 1980. So that's in the top. And then the change, that change in warming between 1981 and 2020. We also understand that not only is it warming and that warming is accelerating, but we are also living these extremes. So it's virtually certain that hot extremes have become both more frequent and more intense across most land areas since the 1950s. I'm going to take a breath there. This is sort of a lot to unpack and feel and acknowledge, because again, we're not talking about projected change, we're talking about observed change. Cold extremes have become less frequent and less severe, with high confidence that human-induced climate change is the main driver. So again, the extremes are here, and we have that very clear fingerprint of our activities on what we are experiencing. These icons are a loose map of the world. There's sort of notes here. You can sort of orient yourself in a region of interest on this global map. And what we're looking at here is the observed change in hot extremes and the confidence that the IPCC is placing in human contribution to that change observed since the 1950s. I've circled the central North American region, which is the region that I am in. I think many of us are in. So I've pulled out the key talking point for this region, but if we're looking at what is Central North America, or CNA, there is low agreement in the type of change in the observed hot extremes. And the confidence is low because of this limited agreement between what we have observed. If we look at our near neighbors in Western North America, in contrast, there is an observed increase in the change in hot extremes since the 1950s. And there's medium confidence that that change can be attributed to humans. They've done the same thing for observations in heavy precipitation. And again, the confidence in the contribution, so is it us, to these changes observed since the 1950s. Here's one where we do have a documented increase in heavy precipitation that has been observed since the 1950s, and a medium confidence that this change, this pattern in precipitation, is linked to human-caused climate change. Just give you a minute to sort of unpack this if you're looking at an area of interest to yourself. So the greater the number of dots underneath the name of the region reflects the confidence, with 3 dots being high confidence in the human contribution. The gray ones, the dashed ones represent low agreement in the type of change, meaning we don't yet know. And then the dark solid gray is limited data or literature. So these reflect sort of knowledge gaps. We're going to look at one more of these, and this is observed change in agricultural and ecological drought. For those folks who have lived in a state that was stressed by drought this last summer, this probably comes as no surprise if you're used to looking at the drought records and the frequency and intensity of drought. But this is the observed change in both agricultural and ecological drought and the human connection, again, observed since the 1950s. If we look at the Central North America region, there is again low agreement in what we have observed meaning there's no clear pattern yet that is emerging from our observations or the literature. And so there's low confidence of human contribution because of this low agreement. So again, I see, while this might be disappointing, in here I see all sorts of opportunities for research and a clear call for the imperative for continued and robust monitoring of all of these things so that we can better understand when the signals and signposts of climate change emerge on our landscapes. So what we do know when we zoom back out to sort of this global perspective is that extremes will worsen. For every additional about 1 degree Fahrenheit of global warming, it causes discernible increases in hot extremes, heavy precipitation, and that agricultural and ecological drought. The agricultural and ecological drought is really more isolated to specific geographies. But this is all to say that, again, the warmer it gets, the worse it gets. And we can see that from the impacts that really matter on the landscape and that we need to plan for, not just a sort of global average temperature change, which is a bit more abstract. So the IPCC loves really complicated graphics. I've done my best to retain the integrity of the graphic while unpacking some of what it means. And I appreciate this might be hard to unpack on a Zoom screen. So I encourage you to look at these in the report or grab, take a quick screen grab if you want to unpack this. But what we're looking at here is now we're looking at projections, not observations. So this is what we might expect in the future. And so this is the projected change in the 10-year event over land. So we're looking at temperature change over land. So the projected change is larger in frequency and intensity with every additional increment of warming. So what we're basically looking at here is the top line and with the little dots, we're looking at the change in frequency of extreme temperature events that occurred on average once in every 10 years. In a climate without human influence. That's the far left. This is the 1850 to 1900, is the pre-industrial period. Sort of everything in this report is based relative to that period. This is the sort of time without human influence. So an event that had occurred once on average in a 10-year period, if we look at every incremental amount of warming, so 1.5 degrees Celsius, I'll throw a box up here. This 1.5 degree to 2 degrees C window is sort of a look into the global policy world. The Paris Climate Agreement sets 1.5 degrees C as our target. There was a report that looked at the difference between 1.5 to 2 degrees C of warming. And so even under the most ambitious climate policies, and trying to limit or not overshoot and then bend the curve back down as close to 1.5 degrees C as possible, we see that these 10-year events are going to 4.1 times more likely to occur. So this is sort of a point that I'll make on a subsequent slide, but we've committed to change, right? And so even under our most ambitious policies, we still are looking at changes in these extreme temperatures, and I'll show you some extreme precip changes as well. The bottom plot is showing you the change in the intensity. So how much hotter will these events be on average? And you can see again, it's not looking good. These outcomes aren't great. I'm going to put on here where some of my colleagues and where there's a growing consensus of sort of where our current policy commitments for emissions reductions will get us is somewhere hovering at sort of just under 3 degrees Celsius. I encourage you to check out Zeke Houtsfather if you're not familiar with his work. He is an incredible communicator and an expert scientist and contributed heavily to this report. And that's sort of the estimate that he's putting out there through his work at the Breakthrough Institute and Carbon Brief. But this is all to say, right, like we've changed things and things will continue to change even under the targets of warming that we have set as a global community. This is the change in the 50-year event. So we're looking at the change in the frequency of these events that are bigger in magnitude. And again, we've committed to a certain amount of change if you cue your eyes there. So we are looking at significant change in the frequency and intensity of these extreme heat events. And we are also looking similarly at projected changes in heavy precipitation. So again, both larger in frequency and intensity, and this increases with every additional amount of warming. And so it is going to be more likely that we have these extreme events and that they will be wetter. So I should have put this slide before. This is sort of breaking down the fact sheet. So that was, again, we were looking at a sort of global scale of the changes in extremes and that pattern of variability. They have produced for the first time these regional fact sheets. This is the North and Central America fact sheet. And again, then this is coupled with the interactive atlas that allows you to even further sort of look at areas of interest and unpack some of the graphics. And they've pulled out the key points. I'm not going to read these here. They sort of re-emphasize what we already said, but changes in extreme precipitation, very likely, increase in pluvial and river flooding, and this change in temperature, both observed and projected, and a shift in the pattern of extreme heat. So again, you can unpack these. These are PDFs you can download and sort of repackage for any of your uses, or if you just sort of want a handy cheat sheet for what does it matter in a geography I care about, you can grab those for a whole set of different of the regions around the globe. And so what we do know, and to reemphasize this, we know we've committed to change. So we also know not only as sort of the patterns of extremes, we sort of some of that is baked in, and the warmer it gets, the worse those will be. We also know that global surface temperature will continue to increase until at least mid-century under all of these emissions scenarios. So under all of the SSPs, this is a plot showing global surface temperature change relative to that pre-industrial period out to the year 2100. This is the amount of global average, the sort of surface temperature change for those different pathways, with red being hotter, right, corresponding to just under 5 degrees Celsius warming by end of century. The thing they have in common is that they basically don't start to deviate. We know we've locked in change. So we know, because of this pretty simple physics of greenhouse gases in the atmosphere, particularly long-lived greenhouse gases like carbon dioxide, that once we emit, we commit. And so this reality is reflective of that physical process. So we know that, and even if we turned off the valve of emissions today, the temperature will still be catching up to those emissions into the future for at least a period of time. We understand that there's now high confidence that the current concentrations of carbon dioxide in the atmosphere are higher than they have been for at least the last 2 million years. I'm a geologist by training, and I still struggle to even comprehend that amount of time. So the extent to that this message is useful or resonant is up for debate. But this is all to say that we have to look way back in the deep geologic record to find a time that is analogous in terms of concentration of CO2 in the atmosphere to today. We also know not only we have baked in a certain amount of temperature change, and we have a big lever for that, right? There's a lot of opportunity there. I'll unpack that in a minute. We also know that we have committed for the long haul for certain changes. So because of these sort of embedded feedbacks, the extent of warming, the rate of response for certain things, say our global ice sheets and oceans, we know that ocean pH is going to continue to decline for a long time. We also know that sea levels are committed to rise for centuries till millennia due to continued deep ocean warming and ice sheet melt. And the sea levels themselves will remain elevated for thousands of years. So for our coastal communities, which represent a significant portion of the global population, the time is now an imperative to prepare. There's no going back to baseline, the baseline to which many of our communities are designed. This is just giving you an updated plot of global mean sea level change relative to 1900 that was in this report. They have this sort of low probability, high impact storyline, which is basically representing major ice sheet instability in western portions of East Antarctica. And that's that high dash line, right? That's not likely to occur, or the least likely to occur, but still physically possible and plausible, but that you'll see that similar to the previous graphs, we're now just looking at meters of global sea level change proportional to the different scenarios. So you do get a corresponding response towards the end of the century in global sea level rise proportional to the emissions pathway that we follow, but we understand that there will be this incremental rise in sea levels moving forward because of the changes we've already set in motion. This report affirms, and this is, again, I've already said this, but I can't emphasize this enough, but the more we emit, the worse it gets. This is why you hear about mitigation. This is why we're hearing about commitments of our global nations to reducing emissions. This is basically just saying very clearly and very simply that there's high confidence, and this aligns with the fifth assessment, that there's a near linear relationship between the total amount of human-produced CO2 emissions and the corresponding warming that they cause. And that is essentially what you're seeing here in this plot. And these are the different range of outcomes in temperature based on cumulative CO2 emissions since the 1850s. You can see on this plot in the gray and the black, the historical warming. So again, this is sort of the baked in warming, and then where our different levers of action or inaction determine the outcomes towards the end of the century. If we want to look at that in more concrete terms, this is a figure that I've sort of made pulling out some of the key projections from this report, which is looking at the end of century outcomes in global surface temperature averaged over the sort of 2080 to 2100 high period. It's very likely under these different scenarios that we could have this range of temperature outcomes. So that very high emissions, this is that SSP 8.5, puts us anywhere between 5.4 and 10.3 degrees Fahrenheit warmer. That is almost impossible to comprehend how fundamentally different our planet would be if that is the path we follow. Intermediate emissions, which is probably in the more likely category, that would put us closer to this 3.8 degrees Fahrenheit to 6.3 degrees Fahrenheit global average temperature change, or average temperature. And this is still in excess of the policy targets that have been set, but probably the most likely scenario based on commitments that have been made. And then the very low emissions, this optimistic scenario actually has us bending the curve back down and being slightly cooler or slightly warmer than the observed warming that we have already that we're already seeing. So therein lies here this critical message, which is that we still choose. And again, just to throw back to the geologic record, the last time global surface temperature was sustained at or above 4.5 degrees Fahrenheit, so this is that sort of middle scenario to very high, was over 3 million years ago. So we are going back into the deep geologic record. And again, we're talking not about a time 3 million years from today, but we're talking about a time only tens of decades away. And I will say, when we talk about mid-century climate, we're still talking about a time when a majority of the global population will be alive and around to experience the outcomes. This is just trying to contextualize. Again, this comes from that regional fact sheet. Like, what does that all mean? This is showing both temperature and precipitation changes, seasonal changes. So DJF is December, January, February. JJA is June, July, August. So this is a winter and summer mean temperature change and corresponding precipitation change for different amounts of global warming. So that 1.5 degrees C target on the top, and then sort of laterally at the very bottom is 4 degrees C of global warming. That's the sort of 8.5, this high emissions scenario. So again, pick a geography of interest here, looking at the sort of broad North American continent, and there is change in store. And we know that we still have the opportunity, but the opportunity is today. It is not tomorrow. It is not in 10 years. It is today, and it was yesterday. We know that global warming policy targets will be exceeded during the 21st century unless there are deep reductions in carbon dioxide and other greenhouse gases like methane, not just in the coming decades, but in the coming decade. So a big premise, and something, of course, that's driving the narrative around climate, is people want to understand, when might we reach this 1.5 degree C or 2.7 degree Fahrenheit target? And that is sort of, there are a lot of reasons why people are asking that conversation. That narrative, again, harks back to the Paris Climate Agreement. This is a graphic from Carbon Brief, an amazing resource. And it is basically showing us for the different scenarios, for these different SSPs, when is it likely that we will exceed that 1.5 degrees C threshold, right? Which is, there are huge consequences for every half a degree, as I've said, and the 1.5 degrees C to 2 degrees C world is profound. We're talking billions more people exposed to heat waves, water shortages, impact on agricultural productivity, worsening of the GDP. Like, you know, what we're talking about here and visualizing here is really significant, even if we're not looking out to that dramatically warmer world. But warming during 21 to 2040 is very likely to exceed 1.5 degrees C under very high emissions. So that means like within the next 20 years, and is likely to do so under intermediate or high emissions. And so we know that the time is now. And again, that future world is not so far off in the future, but it's within the lifetimes, as I would dare say, a majority of us tuning into this webinar and able to read this report. The silver lining, the good news, is we've got a ton of different ways to get there. In the same way that we use global climate models, we've got models that show us what happens if you turn the dial on the proportion of renewables, reduction in coal, like you name it, we can twiddle the dials. That's what all of these little spaghetti diagrams show you here, all these little lines. This is showing us the multitude of pathways and combinations of ways that we can reduce emissions to achieve the sort of the limiting the warming to 2.7 degrees Fahrenheit. This comes from the special report on global warming of 1.5 degrees C that was part of the special report and the 6th assessment process. The one thing all of these pathways share in common is that we need steep near-term reductions, and we need significant carbon dioxide removal or negative emissions by about 2050. So to sum all of this up, how we feel climate change depends on two things. How will we prevent further warming? These are the pathways. This is emissions reductions. And then critically, how will we prepare for those changes that we've set in motion? These are commonly referred to as mitigation and adaptation. Recent research shows that those terms mean nothing to a lot of people and are very complicated. And so it's imperative to all of us to reduce the barriers to entry to these conversations and engage people in understanding not only the impacts, but the opportunities that come and the different ways that we can all contribute to responding to and limiting the amount of future climate change and its impacts on our communities, our infrastructure, and our ecosystems. There is a place for everyone and every solution in this challenge. These impacts, while we're talking about temperature and precipitation and extreme heat, you may not see yourself in that story. You may not have lived or can relate to that. But we all rely on infrastructure and economies and institutions that are built on a premise of a stable climate. This report highlights very clearly that that's no longer the climate that we're going to have and that we will get in the future. And so as we seek to address these impacts and prepare for them, both through the prevention and the preparation, we need to be thinking about all these complex interactions and leveraging the skills and expertise we have to contribute to one or as many of these as we want, right? Climate change is about our health, it's about our ecosystems, it's about our land, it's about water, energy, our built environment, our transportation systems, right? It is all of these things. And so we all should be able to see ourselves in some part of the climate story and the climate solutions. And critically, how we adapt requires connecting some pretty important dots between this new climate reality that is increasingly and repeatedly being outlined in stark detail by things like the Intergovernmental Panel on Climate Change, and likely soon in the US, the Fifth National Climate Assessment. We are seeing these changes, and we really need to start preparing individuals and institutions for these things. We need to be advancing climate-informed decisions across landscapes and sectors. We need to be building and designing resilient infrastructure. We need to be thinking about how to ensure we have or start to be able to consistently deliver functioning and reliable water and waste management services. We need responsive and equitable health systems. We need to be thinking about what does climate smart conservation agriculture look like? How do we deploy it? How do we use these things to solve complex problems? Of course, we need to preserve and protect our natural and cultural resources and identities. And in many cases, as this scientific report highlights, we know enough to act. We have known enough to act. And in many cases, of course, there are lots of nuances, but what we see and what we project is basically what we get. So we've had enough information to act, and the clock keeps ticking, and we really have no more time. Climate change critically is an important opportunity to multisolve. So while it is a challenge, while it will stress us, while it is going to profoundly alter society, we have an opportunity to make that for the better, to improve community resilience and help and address all sorts of social, economic, and environmental stressors that already impact our communities today. And of course, there's a critical conversation. Not all of us will be there, but we can be watching and holding our elected officials accountable for making change. And I will note that there are well over 500,000 elected officials in communities in the United States. So even if you don't feel like our federal representatives are going to do much, or you can hold them to account, there are all sorts of people who make decisions on our behalf every day that we put in office to think about our future and to design and make those decisions on our behalf. And this should be critically part of the conversation. So if you only remember one thing from this presentation and you don't want to do a deep dive into the science, that while there's a ton of nuance and incredibly impressive work that my colleagues have pulled together and that some of you probably have helped pull together or your science has contributed to the report itself, it's very clear that there's an urgent need and a clear opportunity and benefits to all, no matter what you care about, for prevention and preparation for a changed climate future. Remember, it's here, it's us, it's everywhere. We're committed. The more we emit, the worse it gets. And critically, we still choose, and the time is today. We know how to do this. There's lots of tools in our toolbox. There's some simple things we can all do. We can be better coordinated and collaborative. We can draw on Indigenous and scientific knowledges. We can deepen public deliberation and engagement around this topic. We can build governance capabilities at a variety of scales to tackle this challenge. And critically, we have to combine our diverse knowledge, expertise, and perspectives and get to work. And whatever that get to work looks like for you is valuable and needed. And I thank you so much for anything you contribute to the conversation or to action. If you want to find out more about this report, this is from the IPCC. They also have slide decks you can download. There's a whole host of information. And if you want a quick primer and that links you to deeper dives, I really encourage you to check out Carbon Brief. I can toss this link in the chat. You can also just search Carbon Brief. It's an incredible resource, deep in the science, but tries to provide some quick access, and some of what was highlighted in today's presentation draws directly on the amazing synthesis and summary work that they produced as a part of this process. And I will end there, and I think we have about 10 minutes for questions.
All right, I'm going to have Laura Edwards with South Dakota State University lead the question period. I had a couple that were direct message to me that I will get to, Laura. In the meantime, I'm going to start a poll, and if you wouldn't mind filling out one more poll, just a couple questions, it'd be much appreciated.
Sure, thanks, Hans. And thank you, Heidi, for that excellent presentation. I know it's a big gold mine of information really in that report, and there's a lot to digest.
Or a headache, depending on the time of day.
Right. If you can see the chat as well, I'm going to draw from there. Kevin Kirsch asked the first question. This is early in your presentation, so while you were speaking, a question about polar vortices in the Midwest and climate instability, if you feel comfortable addressing that.
I'm going to do the classic scientist thing and say, well, I'm not an expert in that. Although I can say, I'm sorry, I feel like a politician whenever I say that. I will say that, yeah, there's increasing evidence that basically that instability in the jet stream is tied to our climate warming. We see this sort of influence not only in the Midwest, but in other regions like the Pacific Northwest, we sort of get this leakage. But I think the broader message, the science is debated. There's increasing evidence. Again, it would depend on who you ask, but I think the broad consensus, without getting in all the weeds, is that yes, we're creating instability in some of these predominant sort of weather drivers like our jet stream, and that has connections and increasingly attribution, the sort of fingerprinting to a warmer world, particularly motivated by the fact that we have the Arctic warming faster than anywhere in the world due to some pretty straightforward sort of physics and climate. So the short answer is yes, and then there's a whole bunch of weeds underneath that yes.
Yep, thanks, Heidi. Next question was referring to your temperature and precipitation trends and graphs that you were showing earlier in your talk about, and Rashmina has a question about the confidence differences between temperature and precipitation and why they're different.
Yeah, part of that has to do both with the simple answer is that it has to do both with the difficulty in observing both of those variables over the instrumental record and our confidence in those. But as we look out towards the future, our global climate models, we have higher confidence in their abilities to recreate and reproduce what we think the temperature is, and there is still less certainty with the precipitation projections themselves. And so it's sort of part of our ability to capture the complex physics in the climate models influences our relative confidence. And then part of it in terms of the observational piece is really about the density of records, the density of observations and studies, because these represent sort of syntheses of the best available science. So they're looking to peer-reviewed publications in specific regions. So that's not to say necessarily around the Midwest, but we can look in other areas where there are sort of data gaps. Part of that confidence is driven by the fact that there's a paucity of information. And so that I think is a really important call for the scientific community is like, how can we mobilize to start filling those gaps? And I'm sure some people will appreciate this. A big part of my career and other headaches that have faced is just sort of the lack of funding for the necessary monitoring. So as we're observing these changes, we need to be able to document the changes on the landscape, which requires that we have rich networks actually observing the changes. And it's harder and harder and harder to fund those sustained comprehensive networks and even just keep them up with the technological advances that are out there for monitoring things like temperature, precipitation, soil moisture, all of these things. So there's sort of this need to both advance the science and make these necessary continued and durable investments in observing and monitoring the changes so we know when we're hitting these signposts, because that's really how this information gets put into practice, right? It's one thing to say the climate's changing and there's going to be all these impacts, and it's another to say go into a comprehensive planning meeting or talk with a producer and say the climate is changing, I need you to do something, but we don't have that information or even the sort of observed changes to substantiate what we're talking about. So broadly we do. And then there's sort of the finer and finer you get in detail, the harder it is to have those sort of effective decision-based conversations.
All right, thank you. I'm going to skip to a private message that Hans received that's kind of related as to what are some of the main sources of error involved in the coupled model intercomparisons, or what might be possible sources of bias and how are those corrected?
Yeah, I will direct folks. Those questions are addressed at length and by the World Research, what the CMIP process, you can look at CMIP 6 and that there'll be information that pops up. While there are uncertainties in the models themselves, and part of that is again trying to capture these complex physics. The precipitation is challenging. We're trying to get clouds right. We're also trying to we look at multiple different types of models all interacting. So like carbon cycle and ocean models and land cover and land use. Anyway, there's a lot in there in the physics. And so there's an advancement in that science. There's certainly things we're still learning, but there are studies that well document that the primary source of our uncertainty moving forward is not the global climate models themselves. it's human behavior. It's our societal decisions related to emissions. So while there will always be uncertainty in projecting these sort of complex physics out into the future, the better we narrow that range of possible outcomes, the better we are, more equipped we'll have, and the more confidence we'll have in those range of outcomes. So really a huge source of the uncertainty is actually human society and our political will and the rate at which we deploy policies to help determine that pathway. Because we have clarity around that, we can reduce the uncertainty in the other spaces. So that's not to dismiss the nuances of the models, but that's a big piece of uncertainty we contend with that sort of drowns out some of the uncertainty in the models themselves. But there'll be more updates to those global climate models through the next process. And it's designed to be really rigorous, to be able to validate across, I think, 49 different modeling groups ran these simulations and were part of the CMIP6 process. So this isn't a standalone group making an independent decision.
All right, we're just at 2 o'clock, so we'll try to get a question or so in here, and then we'll save the chat and we can direct reply. Hopefully, I think we have names of those other people. So Emily asked about the name, and I didn't catch it either. You mentioned a science communicator during your temperature and extremes slide earlier on, and we didn't catch the name of that guy. So
yes, Zeke Housefather is his name. ZekeHausfather. He was a contributor to the report, incredible communicator, great on Twitter, and is a leadership role at what's called now the Breakthrough Institute, previously at Carbon Brief. But it's an amazing researcher, communicator, and unpacks a lot of this. So yeah, can't speak highly enough of Zeke.
Excellent. And maybe another brief question from Jonathan about how heavy precipitation is defined in the report.
That's a good question. And it was one of the things on my to-do list that I was meant to look into, which is like exactly how are they defining heavy precip, because I needed to remind myself. So I don't have the answer for exactly how they've defined that threshold, understanding that we all have varying definitions of what that means. So I apologize that I did not check the report for that exact definition before doing this. I just can't recall. I literally have it in my notebook and didn't. So thank you to that questioner for poking a hole in my preparation for this webinar. I apologize. I don't have that right at top of mind.
That's okay. I did personally look at the report last week too, a little bit in depth for another group I was visiting with, and they refer to 1-day events and 5-day events. But yeah, it was kind of tough to find if there's a return period or something.
Yeah, what does that mean? Yeah, I'm sure it's in the supplementary material. And if I can find it quickly, we could probably even just all DM Zeke on Twitter. He probably knows exactly. But if I can find that information, I will let you all know.
Okay. And I think the last question we'll have here today, also from Jonathan, about human adaptation to weather and climate. If there's any hope that humans will continue to adapt well, assuming that we don't cut off carbon energy in the next few decades.
Well, I think we have no choice. There are increasingly arguments around the limits of adaptation. I've actually seen this language in some recent New York Times reporting. As someone who studies adaptation, I will say I don't think we're anywhere near the limits of adaptation. So I disagree with that premise. I don't think we've barely scratched the surface for trying to deploy adaptation at scale for the future climate impacts we know we're going to face. But there's no question that the consequences of serious warming will challenge even the best adaptation strategies. And so as we think about adaptive management, right, we know we can't plan. In most cases, we can't plan for the worst possible outcome, but we can't do nothing. So the big question is what do we do and what level of risk do we manage for different things, right? And that question is incredibly nuanced, even within a single community. How you adapt your hospital infrastructure is going to be very different than how you adapt your green spaces and what amount of risk you're willing to assume and what future you plan for. But I think certainly there there are going to be limits, and there's going to be climate migration, a whole host of things that stress our communities. And so the imperative to be proactive rather than reactive. I mean, there are so many, pick your case for why that is a good value add or a good benefit. It doesn't have to be climate. I think it's, even at the context of climate, it's a fiscally smart decision to try to shift our stance from being reactive and being proactive. And those early investments are going to have big wins, and that's, financial and otherwise. And so I don't think we should be talking about the limits yet, but knowing clearly that there are huge consequences if we do nothing. And there are huge consequences even for the amount of change we've committed to, and the amount of change that we're trying to limit global warming to. That 1.5 degree C to 2 degree C world is still a world that's profoundly different than the one that we are living in today, and that many of us have benefited through for our lives. So we need to buckle in, and all of us need to get to work in whatever ways we can.
Great. Thank you, Heidi. A lot of kudos in the chat there for you. And Hans, I don't know if you need anything else to wrap it up today.
I don't believe so. I appreciate everyone's attendance and for filling out the polls and interacting and the great questions. We'll hope to see you on another webinar as soon as December.
Thank you so much.